Hey man, great to see you wearing a mask. Oh, thanks so much, man. Never mind. What's happening, guys? My name's Nicholas Renat, and in this video we're going to be building our very own real-time face mask detector. Now, what's really cool about this video is that these same techniques can be applied to a whole range of use cases. So if, for example, you wanted to train a custom object detector for your specific use case, you can use these exact same techniques to do that. Let's take a deeper look as to what we're going to be going through. So in this video, we're going to be covering everything from start to finish in order to build a real-time custom object detector. Now, we're obviously going to be doing it on face masks, but you could apply this to a whole range of other use cases. So if you wanted to build a custom object detector for your use case, you could use these exact same techniques to do that. So we're going to start out by labeling our images using the Python labelImg package, and then we're going to leverage techniques like transfer learning and the Tensorflow object detection API to be able to train our model a whole heap faster. And then last but not least, we're going to be leveraging OpenCV to actually make real-time detections. Let's take a deeper look as to how this is all going to work. So first up, we're going to be preparing our images using the labelImg package. So this is going to allow us to label different face masks on our face. Then what we're going to do is we're going to train our deep learning model using the TensorFlow object detection API. And specifically, we're going to download a pre-trained model and then apply transfer learning to train this a whole heap faster. And then last but not least, we're going to make those real-time detections using OpenCV and Python from within our Jupyter notebook. Ready to do it? Let's get to it. Alrighty, so there's quite a fair bit to get through in order to build our real-time object detector. Now, broadly, what we need to do is first up label our images, then set up our training repository, train, and then make those detections. Now, in order to simplify that process a little bit, what I've gone and done is I've created a template project inside of Github that you can download and start from. Now, in this case, what we're going to do is we're going to clone that repository and kick off from there. Now, in order to get to this repository, all you need to do is go to github.com/knickknocknack/real-time object detection, and you'll be able to clone that. So let's first start out by cloning this repository. So we can just copy this particular link, then go to our alternate desktop, and then what we're going to type in is git clone and then the name of our repository. And you can see it's cloning and we've already got our file there. So this might take a little bit of time to run, so let's just let that run and we'll be right back. Okay, so that's our baseline repository clone. Now if we step into it, so in this case you can see it's called real-time object detection. We've actually got a pre-written Jupyter notebook, which I've gone and pre-written, which allows you to go through this entire tutorial without writing much code at all. So if you wanted to skip through this and not write the code, you can just go and use that. If we step into this folder called TensorFlow, this is where the majority of the work is going to happen. Now inside of here, we've got two folders, so scripts and workspace, and eventually what we're going to do is we're going to clone the TensorFlow object detection repository into here as well. Inside of scripts, we've got one file called generate TF record, and this is from the official TensorFlow object detection tutorial. So that basically helps us build a TF record, but we'll talk about that a little bit more later. Then if we open up Workspace, we've got a couple of folders here. So we've got annotations. So this is where our label map is going to go and all the stuff that we need to actually train our model. We've also got an images folder. So when we start our labeling, we're going to throw our images in there. We've also got a model folder, and this is where the majority of our model stuff is going to go. And we've also got a pre-trained models folder, which already has a pre-trained model. So in this case, we've got a single shot detector, and we're using MobileNet and the 320 by 320 pixel version. But I'll show you where to download different models and how to use those as well once we get through that part. Alrighty, what we're now going to do is we're going to download labelImg. So labelImg is an awesome Python package that helps you label your images for object detection. So what we're going to do is we're going to go and grab that repository. So similar to what we did for this particular one, we're then going to go to the labelImg repository. Now, in order to get this, you just need to go to this GitHub link. But again, all of these links are going to be available in the description below, so you can grab them and just run with them. So we're going to grab this one and we're going to clone that as well. And again, we're going to type in git clone, and then paste that link. And this should appear within our same folder. So you can see that we've got labelImg that's cloning now. So let's let that clone down and then we can kick things off. Okay, so that's labelImg now cloned. Now what we're going to do is we're going to grab our labelImg repository. So in this case, you can see it here. We're going to cut that and we're going to paste it inside of our TensorFlow folder. So in this case, we've now got scripts, workspace, labelImg, and then eventually we're going to have models. Now, what we need to do in order to set up labelImg is run a couple of commands. So let's cd into that folder. And then before actually going and using labelImg, we need to also install a couple of dependencies. Now, there's two key dependencies that we need. So we need pyqt equals 5 and we need lxml. So I've already got those pre-installed, but let's take a look at those commands. So in order to install pyqt, we just type in conda install pyqt equals 5 and then run that. And then we need to install lxml, so let's install that. So to do that, we just type in conda install -c anaconda lxml. Let's make this a little bit bigger so we can see it. So you can see we've just written conda install -c anaconda lxml. So let's run that. All right, so now that that's done, we just need to go and start setting up our binaries. So inside of the labelImg folder, so in this case, we're still inside of real-time object detection TensorFlow labelImg, we just need to run this command. Okay, so what we've written is pyrcc5, so this is using our pyqt file, and then we're passing through -o resources.py resources.qrc. This is in the official labelImg documentation, so we're just going through the normal setup steps. So let's run this. And then what we need to do is open up the labelImg folder, and we need to grab this resources Python source file and this resources.qrc file and paste it into the libs folder. Now, if you're working on a Windows machine, then there's one last change that you need to do that I encountered when I was setting this up, and this is going to just make labelImg work when we're working with directories. So what we need to do is we need to open up our labelImg folder. And then what we need to do is scroll down to line 1114, which is down here somewhere. And rather than having a /, what we need to do is just change this to os.path.sep and then hit save. So that's just going to make sure that our labelImg library works well with the Windows file directory. All right, so now that that's done, we can go back and then we can start using labelImg. Now, in order to use labelImg, we're going to need some images. So in this case, I've already got some images here. So inside of our all images folder, and you can see some of them don't have a mask, and then some of them I do have a mask. Now, if you want to learn how to capture these images using Python as well, I'll include a link somewhere above to the video where we actually did this. So for the last face mask detection tutorial, which wasn't real time, we actually went and captured these images ourselves using Python and OpenCV. In this case, we're just going to reuse these images. There's also a great Kaggle library that has a great data set on face mask detection as well. I'll include a link to that in the description below. In this case, we're all good. So we're just going to grab this folder, so all images, and we're just going to cut it. And then inside of our TensorFlow folder, inside of our workspace, and inside of our images, we're just going to paste that there. So basically inside of our workspace, inside of images, we should now have 3 folders. So all images, test, and train. There's nothing in test and there's nothing in train. We're going to set that up in a sec. So now what we want to do is we actually want to start labelImg. So to start labelImg, what we need to do is we actually just need to run the labelImg Python file. So to do that, inside of the labelImg directory, we just run python labelImg.py. And when we do that, we're going to open up labelImg. So what we can do from here is we can actually start to label all of our images. Now, in this case, the format that we're going to be outputting to is Pascal VOC. So this is a common format that we use for object detection. Now, in order to make our lives a little bit easier, just make sure when you open up labelImg that you go to View and hit Auto Save Mode. So this is just going to make sure that all of your labels are saved. Now what we're going to do is first set up our save directory. So this is where our annotations or our labels are going to go. And then what we're going to do is we're going to open up our folder that has our images in it. So first up, let's change our save directory. So to do that, we just need to hit change save dir here. And what we're going to do is inside of our real-time object detection folder, what we're going to do is we're going to save it inside of our images folder or our all images folder. So basically the file path should be real-time object detection, which is our GitHub repo, Tensorflow, workspace, images, all images. So we're going to save it in the same folder that our images are in. And then to do that, we just hit select folder. And then what we're going to do is we're going to open up the images that we want to label. So to do that, we just hit open dir. And in this case, it's going to be the same folder that our images are in. So we can go back, select real-time object detection, Tensorflow, workspace, images, and all images, and all of our images are in here. So we can hit select folder, and this will open up all of our images ready for labeling. Now, a few quick tips when you're working with labelImg. The shortcut W is going to allow you to draw a label, and A and D are going to allow you to skip between the next image and the previous image. So if we hit W, then we're going to be able to access our labeling tool. And in this case, we want to label from the nose down. So this is going to give us the best results on a small data set. So in order to label, all we need to do is go, say, around about there. And then what we're going to do is select that and then type in the name of our label. So as soon as you select your square or draw your square, you're going to have the option to type in your label name. In this case, we're just going to label it no mask. And then what we can do to go to the next one is just select D. So, and then we can hit W again, likewise, and then no mask. And then just keep going through. So let's go on ahead and power through the labeling of the no mask images, and then we'll take a break, and then we'll take a look at how to label images with the mask label. So in this case, let's hit OK and keep going. Okay, so that's all of our no mask images done. Now what we want to do is label our mask-based images. So again, similar process. We're just going to hit W, and then this time we're going to label our mask. So rather than having a no mask label this time, we're just going to type in mask. And so that gives us our two different labels. So the ones without a mask had a label of no mask, and the ones with a label have a label of mask, or the ones with a mask have a label of mask. All right, then keep going forward. And that's about it. So it looks like we've labeled all of our images. So if we hit D, we're not going next anymore. Now what we can do is actually take a look at what these annotations look like. So if we open up our directory, now you can see that we don't just have images, we've got all of these XML files as well. And ideally we should have double the number of files that we started out with, because now we don't just have the image, we've also got our annotation. So if we actually open up one of these, you can see that we've got a fair bit of information in here. So we've got the folder that it's in, the file name, so in this case whether or not it's JPG or PNG. We've also got the file path, the source, the size and depth. So in this case it's an RGB image, so you're going to have the width, the height, and then the number of channels. If you've got PNG, you might have a depth of 4 because there's a transparency or opacity layer as well. And then this is the bit that we're most interested in, so this object. So first up we can see the label, so in this case this image is no mask. So if we actually go and take a look at the image that's attached, you can see that it's no mask, and we can also see the bounding box. So these two components are most important, so this label and then this bounding box. So here we've got the different coordinates for the box that actually represents our object. So that's about it. Now you can see that we've got a whole heap, but what we actually want to do is we actually want to split this up into training and testing. Now we're just going to grab the X or top X number to put into training and then grab the rest and put it into testing. But really you could use a much better sampling method for this if you want it to be a little bit more accurate or precise. In this case, in the interest of time, we're just going to grab a couple and throw them into train and then grab the rest and put them into test. So let's go on ahead and do that. So we're going to start up here, and then let's make sure we've got some different styles of images down here. Looks like these are all masked. We have some with no mask. What we'll do is we'll grab these and we'll put these inside of our training folder. And then let's take a look, make sure we've got some no mask ones, and then we'll grab all of these. And make sure you select both the image and the label file as well. So we're going to grab all of those and throw them into our training folder as well. So ideally, if we take a look at all of our images, you can see that we've got a mix of no mask and we've also got a mix of masks. So if we go back into our testing folder, into our all images folder, likewise, if we take a look, we've got some images without a mask and we've got some images with a mask. Now again, we don't have a lot of images, so later on when we take a look at performance, What you could also do is add more images. You could also grab a Kaggle data set and pull that down and use that as well. In this case, we want to do it pretty quickly. So let's take a look at how, so we'll evaluate what the performance looks like towards the end. And then we're going to grab all of these images and put the rest in test. Now what we can start doing is actually writing our Python code to actually go and build and train this model. So what we're going to do is we're going to jump into a Jupyter notebook. So in this case, I've got a Jupyter notebook here already, and we're going to step into our real-time object detection folder. And again, if you didn't want to write this from scratch, you can open up the tutorial Jupyter notebook and it's got all the code you need to get started. If you wanted to train this on a custom model, or the core thing that you need to do is update this label map. But again, we're going to be writing all of this from scratch and taking a look. If you don't want to write all of this from scratch, you can skip to later in the video and we're actually going to be testing it out. But in this case, we're going to walk through it and actually build it up ourselves. Now, rather than stepping through this entire notebook, what we're actually going to do is we're going to write this code ourselves just so we get a better feel for what's actually there. So in this case, what we've got is I've also set up a template. So this isn't in the GitHub repository, but let me know if you want me to post this up. It's basically this tutorial without the code. So we're going to open up our template. And in this case, we've got about 8 different things we need to do. So first up, we need to set up our paths, then create a label map. So a label map is what the Tensorflow object detection library uses to represent our labels. We then need to create our TF records. So TF records are the representation of our data that the object detection API uses. We're then going to leverage some of our pre-trained models. We've already got some, but I'm going to show you where to get others. Then what we're going to do is we're going to set up our model config, train our model, and then we're going to go and perform that real-time object detection. So let's first start out by setting up our paths. So in this case, we've got a number of paths within our directory. So if we actually go and open that up, so basically what we're going to do is we're going to set up paths for everything that's within here. So it just makes it a little bit easier when we're referring to it in our Python code. So let's go and do that. Okay, so those are all of our paths set up. So there's quite a fair few there, but let's quickly go through them. So we've got our workspace path, and this is our main workspace. So if we go back, that's basically this. Let's go back to here. That's basically this workspace that we've got in here. And basically all the others just refer to the other paths. So if we take a look at the rest, so we've got a scripts path. That's where our generate TF record script is. We've got our API model path. So what we're going to be doing is we're going to be downloading the TensorFlow object detection model library from GitHub. So we're going to grab that. We've also got our annotation path. So this is where our label map and our TF records are going to go. We've got our image path. This is where we did our labeling and where our images currently are. We've also got a model path. So this is where our trained model is going to go. So when we actually train this model, what we're going to get is a number of checkpoints that we can then restore from in order to build our real-time detection model, or in order to actually make that real-time detection. We've got our pre-trained model path. So what we're actually going to be doing is we're going to be leveraging pre-trained object detection models to transfer learn and basically build our model a whole heap faster. We've then got our configuration path. So when we're using the object detection API, what we're actually doing is we're using a config file, and this basically gives us all the details for the deep learning model that we're actually going to be using. And then we've got our checkpoint path. So within this folder, all of our checkpoints are going to be there. So our config path is actually pointing directly to our pipeline.config file. All right, so now that that's done, the next thing that we need to do is actually create our label map. Now, our label map is just a representation of all the different objects that you can expect to find within our trained annotation, so those XML files. Now remember, we had one that was named mask and one that was named no mask. So what we basically need to do is just create a representation of that. So let's go ahead and do it. Okay, so that's our labels dictionary. Now what we need to do is actually output this into a label map. So when working with the TensorFlow object detection library, this needs to be in the format of PB text. So it's protobuf file, and this is just what the object detection library likes to use. So let's go on and output that. Okay, so that's our label map done. Now if we go and open up our folder directory, we can close labelImg now, we don't need that. So if we go and open up our annotations file, you can see that we've now got this label map file. So if we actually open that up, you can see that what we've actually got in here is two items. So in this case, item 1 or item 2, and this one represents our mask, and then this one represents our no mask down here. Ooh, these should actually be numbers. So let's just quickly update that code. So we just need to remove the quotes here. Let's try that again. And we need to remove this slash. Save that and run that. Perfect, that's looking better. So we've got our mask as a string and our ID as a number. So if we actually go back now, you can see that basically the code that we've written is we're going into our annotation path and we're creating a new file called labelmap.pbtext, and we're setting that to write because we're going to be writing to it. And then we're looping through each one of these labels. So in this case, we've got two labels, so label 1 and label 2. And then in order to work with our PB text file, we just need to write these out into a specific format. So this first line is writing that item line. The next line is writing the name line. The line after that is writing our ID. And then the final line is basically closing it out. So that's our last set of curly brackets that you can see here. Okay, so that's our label map done. Now our next step is to actually go and create our TF records. Now, in order to do that, what we're going to be doing is we're going to be leveraging the script that we've got within our scripts folder. So this particular file here, so generate TF record, is actually from the official object detection API tutorial. Now, if you actually go into that tutorial, there's a whole heap of information on how to actually do this. I've just simplified it a little bit. But that generate TF record file is so critical because it makes sure that you get your data in the right format. Now, in order to run this TF record or generate TF record script, we're just going to be executing a command inside of our notebook. So let's go on ahead and write that command. Alrighty, so that's all looking good. So basically what we've done is we've gone and used a Python command, and then we've gone into our scripts path and then / generate tfrecord.py. So this is basically allowing us to pass variables from our notebook to our command line. So our scripts path, which is basically this here, so TensorFlow /scripts / generate tfrecord.py, and then we're doing a similar thing for all of these other components. So then we're passing through our image path. So in this case, we're first up doing our train path, and then we're passing through our label map, which we just set up here, and then we're specifying what we want the name of our output to be. So in this case, we're specifying -o, passing through our annotation path, and then specifying train.record. Now, this has done it for our training images. We also need to do it for our testing images. So we can copy this as well. And then all we need to do in order to do it for our testing images is change this to test and change this to test. And run those. Okay, so if all of that has gone well, what you should effectively get out of this is 2 lines printed out. So successfully created TF record file, and then it will specify where those have actually been created. In this case, they've gone and been created inside of our annotations folder. So if we go to that folder, so remember our annotations folder is available through so our main folder, Tensorflow, workspace, annotations. And in this case here, you can see that we've got our label map that we created, but we've also got our test TF record, which is going to be huge, and it's not going to be readable, but that's fine. And we've also got our training TF record file as well. Again, this one's going to be pretty big because it's got more images. All right, we don't need to take a look at that, and we can close those. All right, so back to our notebook. Alrighty, so now that that's done, the next thing that we need to do is go on ahead and download the TensorFlow model library. So this is basically everything that you need to actually go and use this object detection API. Now, a key thing to point out is that in order to run this tutorial, you need to have the object detection package installed already, and I'll include steps to actually do that, and let me know if you want a video on that. I can definitely make one up and go through that. But basically, you just need to run through these steps, and I'll include a link to this in the description below. But what we're going to be doing now is we're actually going to be downloading the TensorFlow models GitHub repo. So let's go on ahead and do that. Alrighty, so under step 3, what we're going to do is just write that command. Alrighty, so the command that we're going to be triggering is first up going to cd into our TensorFlow directory. So this is going to clone it into our TensorFlow directory to keep everything nice and neat. And then what we're going to be doing is cloning this repo here. So if we actually open this up, this is basically the TensorFlow model garden, and it's also got all of this good stuff. So this is what we actually need to go and train our model. Now we can just go and trigger that command, and this is going to go and clone that repo. So this might take a little bit of time because there's actually quite a fair bit in there. Alrighty, now that that's all done and cloned, if we go and take a look at what we've just gone and cloned. So if we go into our TensorFlow folder, you can see that we've now got that available there. So this is going to be key to when we actually go and train our model. Alrighty, back into our notebook. So the next thing that we need to do is actually go and set up our model config. Now, whenever we're training using the object detection API, we basically build a model from a model config. Now, I've actually included one of these already inside of that pre-built repo. So if we actually go into the TensorFlow folder, go into your workspace, go into pre-trained models, you can see that we've already got this pre-trained model here. So it's called SSD MobileNet FPN Lite, or V2 FPN Lite 320 by 320, Coco 17 TPU 8. Now this is from the TensorFlow model zoo. If you wanted to go and use a different model, however, you could definitely go and do that. All you need to do is go on ahead to the TensorFlow model zoo, and there's a whole heap of them here. So if you wanted to use a model which is more accurate, then basically all you need to do is look at the mean average precision score and then pick your model based on that. If you wanted a model that's faster, then you can pick one based on speed. So in this case, what we've done is we've optimized for speed because we're going to be performing real-time object detection. And what we've done is we've actually grabbed this model here. All you need to do in order to grab these is just click on the link and it will actually go and download that file. And then what you can go and do is go and untar that using the tar command. Now, I've actually included that code inside of the baseline tutorial. So if you wanted to do that, all you need to do is pass through the link to the model that you want to use and then just paste it into there. In this case, we're just going to leverage our existing model, but what we are going to do is we're going to grab that config from that baseline file and use that in our own model config. So you can see in there that we've got this file called pipeline config, and that basically is a representation of the model. So you can open that up. And you can see in here, we've got the number of classes available. We've also got what the image resizing is going to look like. So in this case, it's going to resize to 320 by 320. And then further down here, this is the section that we actually need to configure. So we need to configure the fine-tune checkpoint, so where we want our model to start training from. And this is where the transfer learning component comes in, because we can basically leverage a pre-trained model and then just fine-tune from there rather than training from scratch. We're also going to change a bunch of these other parameters as well to make sure that we get a model that's suitable for us. So let's go back into our notebook, and what we're going to do is first up copy that model config into our training folder, and then we're going to make our changes. Alrighty, so that's our config transferred. Now, if we go and take a look at what that's actually gone and done, if we can close that pipeline now. So if we go and take a look inside of our workspace, if we step into our models folder, what this has actually gone and done is created a new folder called my_SSD_MobileNet. And this is basically taken our pre-trained configuration file from that pre-trained model zoo model that we downloaded from the Tensorflow model zoo and pasted it into here. Now what we're going to do is actually configure this pipeline config to be specific to our model. So we're going to point it to our TF records, and we're also going to change a couple of other parameters depending on our hardware. So let's go back to our notebook and start making those changes. So first up, what we need to do, so if we actually take a look at the commands that we wrote, we basically specified the custom model name. So if you wanted to change the folder name, you can change that. And then what we've gone and done is we've used the make dir command to go and create that directory first up. And then we've used the cp bash command to copy that pipeline config. And in this case, see, this is where all of our pre-trained paths come in handy because we don't need to write them every single time. And then we've copied it into the model path, which was specified up here, over there, so /models. And then we've pasted it into our custom model folder, which is called my_SSD_MobNet. Cool, so that's now done. Let's go on ahead and update our config. Now we need to import a couple of dependencies first. So specifically, we need to import Tensorflow. We need to import our object detection utilities, so including config util and pipeline pb2. So this is going to allow us to work with protobufs. And then we need to import text format from Google Protobuf. So let's go on ahead and import those. Okay, so now that that's done, what we want to do is we actually want to open up our configuration file from our models folder or our custom models folder. So first up, we're going to set up our configuration path. So we're actually going to set up a path to that file. Then we're going to open it up, make those changes. So let's first up, set it up, grab it. Okay, so we've now gone and grabbed our config. Now I just realized we skipped over our import, so let's quickly go through that. So we've imported Tensorflow as TF, and then from our object detection utilities, we've imported config util, which we're about to use here. And then what we've also done is we've imported pipeline pb2 from our object detection protos library, and we've also imported text format from Google Protobuf. But we'll talk a little bit more about those once we get to them. Then what we've done is we've gone and set up our configuration path, and this is specifically where our custom model pipeline config resides. So in this case, it's within our model path, within our custom model folder, which is my_SSD_MobNet, and then we've just grabbed the actual file. And then what we've done is we've used our config utilities to go and grab that. So specifically, we've used the get configs from pipeline file method to go and grab that config. So if we actually take a look at this now, you can see that that same config that we opened up in VS Code or Visual Studio, I can't remember which one, we've now brought it into our notebook. Now, by doing this, what we can actually begin to do is make changes to that. So right now, that particular config is configured to go and predict 90 different classes, and it's also configured on classification. So if we scroll further down, you can see that right now our checkpoint type is on classification, but we want to change this to detection. Now, rather than going and doing this manually each and every time by opening it up, we can actually write Python scripts to go and make those updates to our config file. So let's go and set up our new config file. And this is where our pipeline pb2 function is going to come in handy. So we're going to be able to create a shell config, and then we're going to write it to our directory and then use that. So let's go and make that change. Okay, so now what we've done is we've created a template pipeline config. So that's this line here. And then what we're going to do is now make those changes. So there's a couple of changes that we need to make. So I'm going to power through them, and then we'll go back and take a look at what we've actually gone and changed. Alrighty, so that's our pipeline config updated. So there's quite a fair bit happening there. So let's actually take a step back and take a look at what we've written. So first up, what we've done is we've gone and changed the number of classes that we want to predict. And this is the same number as the number of classes that we've actually labeled within our images. In our case, it's 2 classes, so mask and no mask. Then what we've gone and set up is our batch size. So pipeline config, train config.batch size, and we've set that to 4. This is really dependent on how much hardware capacity you've got available. So if you've got a GPU, you might be able to bump that up higher. If you don't, you might want to drop that lower. Then we've also specified our fine-tune checkpoint. So remember, we downloaded our pre-trained models, or I had them inside of that GitHub repo. What we're basically doing is we're telling our config where we want to start training from. And in this case, the checkpoint that we want to start from is called checkpoint 0. So this file is actually within our pre-trained models directory. So if we go back to our workspace, go into pre-trained models, go into this folder here, which is just from the model zoo, you can see that within our checkpoint folder, we've got our checkpoint. So these actually represent where our model was last trained to. So we can pick up from there and then just fine tune from there. So now if we go back in, then we've also specified that we want to train a detection model. We've specified where our label map path is. In this case, it's our training label map path. Then we've specified where our training records are. So remember, we created those TF records just up here or there. What we're now doing is within our configuration, we're saying that our training records are within our annotation path, and then they're actually in the train.record file. Likewise, we're doing a similar thing, but these 2 lines are doing it for our testing components. And if we actually take a look at our pipeline config, you can see that this has actually gone and made those updates. But we haven't actually gone and updated that file within our directory yet. We've just got it inside of memory within our notebook. So what we actually want to do is go and write out this config file. And once that's done, we can actually go and train our model. So let's go in and write it out to our directory. Okay, so now what we've gone and done is we've written out this pipeline config, or our new pipeline config, to our directory. So in this case, what we've done is we've used our text format utility. So remember, we brought that in from google.protobuf. And what we've gone and done is we've converted our protobuf message to a string. Then what we've done is we've gone and written it out using these 2 lines here. So if we actually go and take a look within our directory now, inside of our custom directory, you can see that our pipeline was just updated. So now we've gone and written down our new pipeline. We can even open that up. And you can see that we've got our 2 classes. And if we scroll all the way down, you can see that it's been updated with all of our new fine-tuned checkpoints and all of our pb.txt files, as well as where our training and testing records are. So that's looking good. Now that that's done, we can actually start training our model. So, all right, now in order to train our model, again, we're going to be now using the TensorFlow models directory. So this is where we start to get to the good bit and actually go and see how our model is going to perform. Now, what we're going to do is we're going to write out our command inside of our notebook, but then we're going to paste it inside of a separate command line terminal, just so we can see the status as it's updating, because sometimes it's a little bit glitchy inside of a Jupyter notebook. So let's go on and print out that command, then we can copy and paste it and start training. Alrighty, so that's all looking good. So what we've gone and printed out, in this case, we've gone and used some string formatting to pass through our different paths. Again, this is where they come in handy. And our baseline script to go and train this model is Python. And then we're going and using the model main underscore tf2.py. So we're using TensorFlow 2 for this particular training model. And then what we're doing is we're passing through where our model directory is. So in this case, it's our custom model directory. So TensorFlow workspace models my SSD underscore MobileNet. Then we're passing through where our pipeline config is. In this case, it's again within our custom model directory, and it's called pipeline.config. And then we're specifying the number of training steps, so how long we actually want to train our model for. And in this case, we've specified 5,000 training steps, but again, you could drop it down, you could change it. It really depends on how accurate you want your model to be. In this case, I've tended to found that 5,000 tends to work pretty well. You can drop it down and it's still going to perform reasonably well as well. And in this case, what we're going to do is just throw it all on one line. So it looks like that. And we're going to grab this line. So we're going to copy that. And then we're going to go into a folder that we've actually got a directory in. And we're going to create a new command line. Then in order to run this, what we're basically going to do is navigate into our real-time object detection folder. So let's do that. Okay, so we're in that folder now. Now all we need to do is paste in that command, and this is going to kick off our training run. So it'll take a little bit of time to start, but once it eventually kicks off, you'll eventually start to see the loss metrics updating in real time. So let's give that a second till we see our first training steps, and then we'll go from there. And there you go. So that's our first loss metric appearing here. So if we open that up, you can see that these 2 lines here identify the fact that our model's training okay. So you can also see the time it's taken to train per step, as well as our current loss. Now, ideally, what I've tended to see is that if you get this loss to below 0.15, the model tends to perform a lot better. But again, train it a little bit, see how it performs, train it a little bit, and then test it again. In this case, we're going to step away and let this train for the next 5,000 steps. Alrighty, so that's our model finished training. So you can see here that we've trained for 5,000 steps, and right now our loss is at about 0.183. So you can see it's sort of varied throughout time, but overall it looks like it's gotten pretty low. Again, we can train for longer if we want. At the moment, let's run with that and take a look at how it looks once we perform our real-time object detection. Now, I should also point out that you could also add additional photos. So I'll include a link to the Kaggle face mask directory. So there's a whole heap of additional face mask or labeled face mask images that you can also add to this to improve your accuracy. In this case, we've only trained on maybe like 40 images or fine-tuned on 40 images. So that's not too bad for now. So let's go back into our notebook, and there's a couple of things that we've got left to write. So specifically, we need to now load in our trained model. So if we actually go and take a look at our checkpoints, we started off with 1, we're now up to checkpoint 6. So we want to load that checkpoint into our pipeline, and then we actually want to go and make detections, and specifically real-time detections using a webcam. So let's go on ahead into our notebook and get started on that. So in this case, we're now up to step 7. So we've done quite a fair bit so far. So we've done all of this. Now we're just up to 7. So load our model and detect in real time. So we're almost there. Now the first thing that we need to do is, first up, we need to load some dependencies. So in this case, we're going to be importing our labelMap utility as well as our visualization utility from the object detection libraries. And we're also going to need the model builder method. So let's go on ahead and import those dependencies, and then we'll take a look at those. Okay, so those are our dependencies imported. So what we've done is we've first up imported OS, so operating system. Then we've imported 3 things from the object detection library. So first up, we've imported labelMap util. So this is going to allow us to work with our label map. Remember, we set that up right up here. Then we've also imported some visualization utilities. So this is going to allow us to transform our detection to an overlay on our image. So you'll actually see the bounding boxes. And then we're also importing our model builder. So this allows us to build our model from our checkpoint and our config file. So now let's go on ahead and load it up and then write our detect function. Okay, so that's our model reloaded. So let's take a quick look at what we've actually written there. So first up, what we've gone and done is we've grabbed our pipeline. And so keep in mind, this is the pipeline that we went and modified. Then we've gone and built our model using our model config, and we've specified that it's not training at the moment. Then from that, what we've gone and done is we've gone and restored our checkpoint. So in this particular case, we've gone and passed through our detection model to tf.compat.v2.train.checkpoint, and we've specifically passed through this detection model here, and then we've gone and restored it. Now, in this particular case, what we've gone and done is we've restored checkpoint 6. So this is the latest checkpoint that we actually went and trained. So if we take a look back in our training folder, checkpoint 6 is our latest one. If you train for longer, you might have additional checkpoint numbers. Use the latest one, or use the latest one that doesn't have any issues. And this ideally should give you the best results. But again, it's dependent on the loss that you've got and whether or not your model performed well. All right, so let's go back into our notebook. So that's loaded. Now what we want to do is write our detect function. So specifically, we want a function that we pass our image to, and then we get our detections. So let's go and write that up. Okay, so that's our detect function done. So basically what we've specified is, first up, this is a Tensorflow function. Then we've called it detect function. So we've basically used our standard Python formatting here. So def detect function, and then we're passing through our argument, which in this case is going to be our image. Then what we're doing is we're first up pre-processing our image. So we're going to resize it down to the 320 by 320. And then we're going to go and use our detection model, which we've defined up here, to go and make that prediction. Then once we're done with that, we're then going to pre-process it again and finally return our detections. Now what we can go and do is actually go and detect in real time. So this is the final bit of this tutorial. So once we've finished this detection function, we're actually going to be able to leverage everything that we've just gone and done to go and detect in real time. So in this case, we're going to be using a webcam to make real-time detection. So you'll actually be able to see the face mask, or whether or not I've got a face mask on my face. So let's go on ahead and write up this function to go and make our detections in real time. And also, just before I keep going ahead, remember that all of this is available in the pre-written tutorial. So if you didn't want to write all this code, or if you wanted to sort of skip through it, you can just use that notebook and it's going to give you the same results. All right, so first up, what we've done is we've imported CV2, which is OpenCV, and we've also imported NumPy, so as MP. So this is just going to help us work with our images. Now what we need to do is just create a category index. So this is again a representation of our label map. So again, it's come in quite in handy. So let's go and create our category index. And then what we're going to do is set up our capture from our webcam. All right, so that's our category index done. So in order to create that, what we've basically done is we've written label map, or we've used the label map utilities, and we've used the function create category index from label map. And to that, we've passed through our label map path. Now what we can do is we can actually output this. So if we take a look at it, it's going to be really similar to what we wrote just before for our label map, except this time what you've got is a key per label map. So in this case, key 1 is going to be mask, key 2 is going to be no mask. Now what we can go and do is actually set up our capture from our webcam, but we won't run it yet. We'll wait till we've got everything written and then we'll trigger that. So let's set up our capture and let's set up our real-time object detection. All right, so that's our video capture done. So this first line here is basically cv2.video capture, and that allows us to access our webcam. Now you might need to play around with this number. So in this case, my webcam is device 0. Yours might be 1 or 2 or 3. Just play around with that if it's not working, or drop a comment below and I can help you out. And then we've also captured our width and our height. Now the next thing that we need to do is actually loop through, set up our webcam, make those detections, and render the results to the screen. So this is quite a large bit of code. So let's write it all out, and then we're going to step through like we usually do. So first up, what we've done is we've basically set up a loop. So while true, it's going to keep through and running this. First up, what we're doing is we're getting our frame from our video capture that we set up here, and then we're converting that frame into a NumPy array. So when we pass through our image, we want it to be a NumPy array in order to work with TensorFlow. Then what we're doing is we're converting it into a TensorFlow tensor, and to that we're passing np.expanddim. So this is just going to put it inside of another array because TensorFlow, or our model, expects multiple images to come through. In this case, we're only passing through one. And we're setting the D type to float32. Then we're actually going and making our detection. So here we're using our detect function, which we defined here, and we're passing through our input tensor. Then what we're doing is we're grabbing our number of detections because we're going to do some pre-processing on them over here. And then we're adding those back. And then last but not least, we're going and grabbing our detection classes. Then we're specifying a constant for our label ID offset. So when we get our detections through, they're going to start at 0. We want them to start at 1 because our category index starts at 1. And then we're making a copy of our detection. So in this case, we're grabbing our image.np up here, and we're calling it image.np with detections. This is because when we pass it through to this function here, so visualize boxes and labels on image array, it's actually going to transform that array. So ideally, we want to have a backup just in case we want to make some changes to it. So to that function, so we're using viz.utils and then visualize boxes and labels on image array. We're passing through that image array that we had up here. So this is our raw image from our webcam. And then to that function, we're passing through our detection boxes, our detection classes, as well as our detection scores. So ideally, when we go and visualize, you should see the detection on our face, and you'll also see the score and the label in the top left-hand corner. Then we're passing through our category index, whether or not we want to use normalized coordinates or not. In this case, you do want that because it's going to make sure that it positions the box correctly on your face. Then we've also got a number of other parameters. So the number of boxes we want to draw, in this case, we just want the 1. The minimum score threshold, in this case, we're going to set it to 0.3. Again, you can play around with this. And whether or not we want agnostic mode set to false or true. So if we set that to false, it's going to see that there's a detection, but it's not going to differentiate between mask or no mask. Then what we're doing is we're displaying it back to the screen. So we're grabbing that transformed array, which we had up here, and we're going and showing it using cv2.imshow. And then if we want to break out of it, we've also set up our regular break key setup that we've got for cv2. So then what we're going to do is we're going to start up our video capture. So this will start up our capture for our webcam. And then what we can do is we can actually start making these detections. So all things holding equal, ideally what you should see is a pop-up on the screen inside or outside of your Jupyter Notebook that's actually showing you those detections. So let's go and run that and see what our results look like. Might take a little bit of time to start up as well, but it should start up. Oh, and we've got a bit of an error. Let's take a look. And this looks like it's an error within our detections function. So let's scroll back up. Let's take a look at that. Oh, this should be post-process. Let's do that again. And let's try that again. And this should be a comma. All full of bugs today. And there you go. So let me drag it onto the screen so you can see what I'm seeing. So this is our real-time object detection. So you can see it's obviously detecting that I don't have a mask. If I cover my face, looks like it's still performing all right. Now, if we do put a mask on, you can see that it's accurately predicting that we've got a mask. Now, keep in mind that this has only been trained with a couple of images and it hasn't been trained all that long. So you're going to have varying levels of accuracy. So, I mean, it's 96, 97. But say, for example, you took the green screen down, then you might have a different level of accuracy. So if we bring this down, you can see, oh, it's still performing all right there. But you can see every now and then it might blow up. Now, the way to improve these models is to train for longer, to provide more data, and you can also perform a number of image transformations. So say you performed a shift or a split, or you applied some blur. So there's ways to improve these models. So let me know in the comments below if you'd like to learn more about how to perform some of those transformations to improve the accuracy of these models. But you can see then it's actually performing pretty well. If we put a mask on, looks like it's detecting a mask. If we try with a different colored mask, so in that case that one's black, you can see it's detecting that one pretty well. And that's real-time object detection. So there you go. So we've gone through end to end. So we've labeled our images, we've set up all of our pipelines, and we've even gone and trained our models. And in the end, you can see that we've gone and built our real-time object detector, which is still detecting in real time, and it's performing pretty well. And that about wraps up this video. Thanks so much for tuning in, guys. Hopefully you found this video useful. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And let me know what kind of object detector you want to be building. Thanks again for tuning in. Peace.